Assalamu alaikum wa rahmatullah. In this video, we are going to continue part 3, which is the last part of chapter 5, Sound Energy. At the end of this part, you will be able to determine the sound intensity level at a point. But before, let's remember the main ideas of the previous part. 1. The sound intensity is the sound power received per unit area placed at a point. I is equal to P divided by 4 pi r squared. 2. The sound intensity at a point is the sound power received per unit area perpendicular to the direction of propagation of the sound at the given point. I is equal to the power received divided by the surface area. 3. For a frequency of 1000 Hz, the standard values are: threshold of hearing I0 is equal to 10 to the power minus 12 watt per meter squared, and the threshold of pain is I is equal to 1 watt per meter squared. We have previously defined the sound intensity, which explains the decrease in the sound when moving away from the source, but this physical quantity seems incapable of explaining the hearing sensation of a person. For example, the operation of two identical loudspeakers connected on the same LFG does not create an auditory sensation that the sound is doubled, even that the sound intensity is doubled. This shows that hearing sensation is not proportional to loudness. In general, for our hearing sensation to double, the sound intensity must increase 10 times, and that depends on each person. For this reason, physicists have defined another physical quantity related to the sensitivity of the ear, which is called the sound intensity level. The sound intensity level in general expresses the auditory sensation and is defined by L is equal to 10 log I divided by I0, where I0 is equal to 10 power minus 12 watt per meter squared is the threshold of hearing. L is expressed in decibel, referring to the scientist Alexander Bell, the inventor of the telephone, and L is measured using this device, which is called the sound level meter. Let us solve application number 6. Determine the corresponding sound intensity level for I0, which is equal to 10 power minus 12 watt per meter squared, and which corresponds to the threshold of hearing, and for I, which is equal to 1 watt per meter squared, corresponding for the threshold of pain. To find the sound intensity level, we have to use the formula L is equal to 10 log I divided by I0. But in this case, we have to find the sound intensity level corresponding for the threshold of hearing, which is defined by L0. And we substitute instead of I0, which is 10 to the power minus 12. Then it will give 10 log 1. And we know that log 1 is equal to 0, so 10 times 0 is equal to 0 decibels. Then the 0 decibels is the sound intensity level corresponding for the threshold of hearing. In part 2, we have to calculate the sound intensity level corresponding for the threshold of pain, and in this case, we have to substitute instead of I1, it will give 10 log 10 power 12. And using the formula log A power n is equal to n log A, then this will give 10 times 12, which is equal to 120 decibels. Don't forget that these values corresponding for the threshold of pain and hearing for the sound intensity and the sound intensity level corresponds to frequency of 1000 Hz. In application number 7, a person A receives a sound of intensity I is equal to 10 power minus 2 watt per meter squared placed at a distance d from an explosion of a firecracker. In part 1, we have to calculate the sound intensity level at A, and in part 2, we have to determine the power P of the firecracker, knowing that the emitted sound wave is spherical and d is equal to 500 meters. In the first part, to find the sound intensity level, we have to substitute instead of I 10 to the power minus 2, then this fraction will give 10 to the power 10, and then This will be equal to 10 log 10 power 10, which is 10 times 10 log 10, and we know that log 10 is equal to 1, then 10 times 10 times 1 is equal to 100 decibels. In part 2, to find the power, we have to use I times 4 pi d squared. When we substitute instead of the 500, then the power emitted will be equal to 3.14 times 10 to the power 4 watt. In part 3, we have to calculate the sound intensity level at A if two identical firecrackers explode at the same time and the same distance d from A. If the two firecrackers are identical, then the intensity received at the point A is 2I. Then, to find the intensity level, we have to substitute 2I by 2 times 10 to the power minus 2, and it will give 10 log 2 times 10 to the power 10, which will be equal to 103 decibels. In part 4, in fact, air absorbs 7 decibels per kilometers. Calculate L prime, the real value of L at a distance d. Here we have to say that L prime is equal to L minus 500 times 10 to the power minus 3 kilometers. Here we have converted from meter to kilometers, multiplied by 7 decibels in 1 kilometer. It will give 100 minus 3.5, which is 96.5 decibels. What are the conditions of an audible sound? The frequency should be audible, that means between 20 and 20,000 Hz. The sound intensity must exceed the threshold of hearing, which is I0. When these two conditions are satisfied, then we can say that the sound heard is audible. Let us take a look on the auditive sensation diagram. The horizontal axis represents the frequency in Hertz, and the vertical axis represents the sound intensity level in decibels. The green curve represents the threshold of hearing for an audible frequency interval. The red curve represents the threshold of pain for an audible frequency interval. The threshold of hearing for 1000 Hz is 0 decibels. A person hears nothing beyond this threshold at 1000 Hz. The threshold of pain is 120 decibels at 1000 Hz. A person has a sensation of pain in the ear when exposed to this level of sound. Point A represents a sound of frequency 100 Hz and at 40 decibels. But it is below the green curve, that means the frequency condition is verified, while the condition of the threshold of audibility is not verified. We deduce that this sound is inaudible. Point B represents audible sound because both hearing conditions are satisfied. Pay attention that A and B have the sound intensity level, but the first is inaudible while the second is audible. Point C represents a sound of a frequency of 400 Hz and 10 decibels, but it is below the green curve. Again, that means that the condition of a frequency is verified, but that of audibility is not verified, then the sound is inaudible. Pay attention that B and C have the same frequency, but the first is audible and the other is inaudible. The area between the curves red and green is where a sound is heard, but without the risk of damage. The blue area represents the frequencies and intensity levels of the human voice, which is the speech. Notice that the area of the speech is very small compared to that of hearing. Because of this, talk less and listen more. It must not be forgotten that to each sound level there corresponds a maximal exposure time. For example, a sound of intensity level 85 decibels, like a city traffic, may cause damage in 8 hours, and that of 85 decibels, like an electric drill, may cause hearing damage when exposed for 48 minutes. And a sound of 100 decibels, like a car horn placed at 5 meters from the receiver, may cause hearing damage when exposed for 15 minutes. A sound of 110 decibels, like a jackhammer, may cause hearing loss in less than 2 minutes. Thank you for watching, my dear students, and please study well.